Welcome everyone to the Explainer for Class 8. Today, we're taking a massive leap from abstract theory straight into the fascinating, and let's be honest, sometimes really messy, real world. Our core mission here, to completely unpack real-world case studies in industrial symbiosis and the circular economy. We're going to look at how these concepts actually play out on the ground, so you're totally prepped for the analysis you'll be doing in your coursework. Let's get into it.
Okay, let's dive into this. We've got a clear, four-part roadmap today. First, a quick welcome to Class 8. Second, the essential vocabulary for success. Third, we're doing a sustainability reality check. And finally, we'll outline your 3 training missions.
So, Section 1, welcome to Class 8. We're just setting the stage here and going over syllabus requirements, clearly knocking out the administrative housekeeping before we get to the fun theory stuff.
Right, here's your visual checklist before you begin the deep work. Make sure you have your Class 8 worksheet ready to go. You've also got 2 foundational readings, Chertoff from 2007 and Ajman Momirsky et al. From 2021. Now, keeping these on hand and thoroughly reading them, and yes, I mean every single page, will help you directly hit those learning outcomes you see right here, LO1, 4, 11, and 12.
Moving right along to Section 2, Essential Vocabulary for Success. Let's move to the glossary toolkit and see how this builds. Get your pens ready, because understanding these next 4 terms is absolutely non-negotiable for analyzing our upcoming cases.
First up, our foundational tool, the case study. In our context, this is a practical, real-world example used for analysis. So we aren't just talking about abstract academic ideas up in the clouds anymore. We're studying actual living examples. Think of things like the famous Kalundborg Eco-Industrial Park, circular packaging systems, construction material reuse, or even how specific cities are handling circular food waste valorization.
Next is resource flow. This represents the movement of materials, water, energy, or byproducts. This is the actual physical or energetic exchange we'll be tracking. You know, like detectives. When a factory's excess steam becomes a nearby facility's heating source, that literal movement is the resource flow. You've got to follow the flow to really understand the system.
Then we've got scalability. This refers to the potential to expand or replicate a successful solution. This one is huge. A brilliant solution in one industrial park might rely heavily on incredibly short local distances, very specific infrastructure, or a unique local market demand. So a key part of your analysis will always be asking, can this scale, or is it totally bound to this specific location?
Finally, stakeholder. A stakeholder is any actor affected by or influencing a decision. Remember, industrial systems don't just run on autopilot. Human actors drive these resource flows. Their active cooperation, whether we're talking about local communities, waste processors, or municipal regulators, is strictly required to make industrial symbiosis happen. No stakeholder buy-in, the system fails. It's that simple.
Okay, Section 3, the Sustainability Reality Check. This is where we break down some major assumptions about circular systems.
Here's a huge question for you. Does circular always mean sustainable? It is so easy to just assume the answer is an automatic yes, but we really need to challenge that preconception right now. To truly evaluate these case studies, we have to adopt a critical life cycle assessment or LCA perspective. We literally cannot just take the word circular at face value and assume it's magically good for the environment.
Now, what's really interesting about this comparison is the stark contrast. On the one hand, we have the simple technical solution, moving a byproduct from point A to point B. Looks neat and tidy, right? But on the other hand, look at the real-world requirements. To actually make that physical exchange happen, you need profound trust between companies, ironclad contracts, complex physical infrastructure, favorable regulation, shared value, and intense logistics. The case studies make it incredibly clear. A technical fix is basically useless without the human, legal, and logistical systems to back it up. Let's look even closer at those hidden logistical realities through that LCA perspective. Yes, replacing virgin materials with an industrial byproduct is inherently a positive step. Absolutely. But that alternative material often requires extensive sorting and cleaning. Moving it generates its own transport emissions. It might demand additional energy just for processing. And hey, even reusable systems have a catch. They require a sufficient number of reuse cycles to actually reduce waste over time. This is exactly why you have to analyze the entire system's life cycle. You're learning to assess the total net impact, not just the highlights.
Section 4, your 3 training missions, putting theory to practice. Let's equip you with your detective toolkit so you can investigate these case studies on your own.
All right, your first mission is Activity 1, creating a case flow diagram. You and your group are going to analyze a selected case study and literally draw out the main flows. The exact expected output here is a complete diagram detailing the actors involved, the specific resources exchanged, whether that's materials, energy, water, or information, and crucially, the specific direction of each exchange. You need to map out exactly who is providing what and who is receiving it. And yep, you're actually going to have to talk to your group mates to figure this all out.
And this brilliantly illustrates what you'll be doing for Activity 2. You'll be constructing a benefits and barriers matrix just like this one. You need to thoroughly evaluate your chosen case across 3 vital criteria: environmental, economic, and social. For each dimension, you'll list the expected benefits, the potential risks or rebound effects, and the real-world implementation barrier standing in the way. Filling out this matrix ensures you're evaluating the whole picture, not just looking at the technical upsides. Your final mission is Activity 3, a stakeholder roleplay. Here are your steps. First, you'll step into the shoes of a specific actor. Maybe you're a company manager, someone from the municipality, or even representing the local community. Second, you'll actively negotiate whether the proposed resource exchange should be implemented and under what strict conditions. Third, you'll produce a brief negotiation summary. That summary has to outline the agreed conditions, highlight any unresolved concerns, and specify exactly what LCA data you would still need to make a final, informed decision.
So, the crucial point is this. As you read through Chertow and Ageman-Mamirsky, and as you map out these flows and role-play these intense negotiations, I want you to keep this final big question front and center. What conditions must be present for a circular economy or industrial symbiosis solution to succeed in your city? Think about that scalability and transferability we discussed earlier. Don't just learn what happened in the case study. Figure out why it happened and if it could realistically happen where you live. Keep that critical mindset razor sharp as you dive into your study preparations. Good luck with your missions.